The notion of rewriting in mathematics, computer science, and logic. This notion covers a wide range of methods of replacing subterms of a formula with other terms. And such methods may be achieved by rewriting systems, also known as rewriting systems, rewriting engines, or reduction systems. And in the most basic form, they consist of we have some set of objects, some set of terms, for example, and some set of relations on these objects or on these terms. How can they replace one terms with other terms? And also, their rewriting can be not deterministic. This means that there is no one certain way how can they rewrite some subterm. It can be done in many ways, and such writing is called non-deterministic because we can from this point split into somehow many branches of the rewriting, and so on, so on. The rewriting system does not provide the algorithm how to change one term to another. It just provides some rules. But if we add this algorithm into the rewriting system, we will receive a programming language, for example, such as Haskell. It has somehow a rewriting engine. It rewrites some terms with other terms with better reduction. And it can be viewed as computer programs or fear improvers or declarative programming languages. For example, if we take logic, the procedure of obtaining the conjunctive normal form can be implemented as a writing system. And here you can see these rules of such system, which says that, for example, we can replace this formula with this formula, or also known as double negation elimination or De Morgan laws. They can replace this thing with this thing, and so on. So these just the rules that show which terms we can replace with other terms. And their writing is also applicable in arithmetics. So we can, for example, take the operations on natural numbers, and each number we encode as some term. And simplest encoding is the one using the Peano axioms. So we have some constant zero, successor function, some numbers which are encoded with our zero term, and this way with the application of successor function. And here they see again these rules how we can encode such type of the system. They say that we can replace this term with this, and this with this, and so on. And here we can see that actually the computation can be encoded with such rewriting rules. So, for example, here they see how the adding of two numbers, 2 and 2, is proceed with these rules. Number 2, we proceeded again and again, and at a final point we have our result of our computation, the number 4. Rewriting also applicable in a linguistic, so we can it used in such things as generative grammars. These grammars generate correct sentences of a language. For example, here they have some they can be represented in such form that A can be replaced with X, where A is a synthetic category, and X is a sequence of such labels or morphemes, and this thing expresses that the fact that A can be replaced by X to generate the constituent structure of a sentence. For example, we can take this rule from S. We can derive NP and VP. It means that a sentence, this is a sentence, S can consist of a noun phrase followed by a verb phrase. And in such way they can construct some concrete sentence. And from seeing concrete examples, we can say that we can go to some notion of abstract rewriting systems. And actually they consist from the set of objects and set of rules. And these rules can be represented as a binary relation, which shows which objects we can replace with some other objects.